Hello, in this video I'm going to be sharing with you how to find the area and the volume of a cube. So this is related to 2D and 3D geometry and nets. So first things first, we're going to do a little sketch of a cube. And the way you do that is you start with a square, and then off of 3 of the corners, you're going to draw 3 parallel lines that are the same length. And then you're going to join those parallel lines like this. That's going to make a 3D perspective drawing. So a cube is a shape that is entirely constructed of squares, that all of the sides or the surfaces are squares. And this is an example here of a cube that I've built out of Magformers. So if I was being asked to find the area of this object, area is a measure of 2 dimensions. I'm going to need to figure out what is the surface area, or the area of one of the squares that makes up one of the sides. If I measure that, use imperial measurements here, each side is 2.5 inches by 2.5 inches. I'm going to label that on my diagram. So 2.5 by 2.5. And 2.5 here as well. So each of the squares that make up this object are 2.5 by 2.5. And I can show there's a square here as well, like this. Okay. So in order to figure out what the area is, I'm going to consider that this object is 6-sided. So I've got 6 square sides. So I'm going to be taking 6, and I figure out what the area of the square is. The square is going to be 2.5 by 2.5, length times width. And I get 37.5. So the area of this cube is 37.5. It wasn't centimeters, I was measuring in inches, so I'll say inches squared. Okay. So that's the 2D part of that shape. Now, the second thing I could consider that I may be asked to find is how much space, how much volume could that object contain? If it was a box or a vase or something like that, how much could I put inside that shape? That's 3 dimensions. So volume is a measure of 3 dimensions. In order to find volume, I'm going to use the same process as I would for any rectangular prism, because actually a square is a kind of special rectangle. So the volume in this case will be length times width times height. And it turns out that all of these measures are the same. So 2.5 times 2.5 times 2.5. Which, if you like, you could also represent as 2.5 cubed. And that's not accidental, that's because it describes the volume of a cube with those dimensions. And then I would use my calculator. 2.5 cubed. 15.625. I could also have typed it in as multiplication like that. And because this is a volume, it's 3 dimensions. So this is inches cubed. We would also say cubic inches. Okay, next we're going to look at the net. In this case, nets. So a cube is a special shape because it has a few different ways that it can be broken down from 3 dimensions into its 2-dimensional pieces. So the most common way that you may have seen for a net of a cube, and often this is how it's drawn out when you're given it in textbooks and things, is kind of a T shape, like this. So that's the first net that makes a cube. So that's flat out 2 dimensions. And if I fold up the sides, it builds a cube. That's not the only net that builds a cube. I could move these, say to here. So I've kept that center row together. Still builds a cube. Okay, back to the T. Okay, I could do this. Sort of an S shape or a zigzag. So that one builds a cube. There's also this one. And maybe you've noticed by now that really what I'm doing is I'm just moving those blue ones from the sides up and down. As long as there's one on each side, it still will build a cube. So I could put them up here even. And that would still make a cube. See? But there's a third, well actually no, 5th net that may surprise you. Which kind of looks like stairs. So this one, when I start folding, so it makes a cube. So the interesting thing about that staircase pattern, there we are, is if you were to consider that this was being cut out of some kind of material like sheet metal or plastic or something, the edges of that material could be like this, and then what you're throwing away in the manufacture of this box are these 4 little triangles. Whereas if I used this layout, or even this layout, if I wanted to cut this out of one sheet of material, I'm having to throw away all of these pieces here. And there are ways that in manufacturing, companies will look at how can they move the nets and lay them out to make the best use of the material that they have available. So, for example, if I was doing the T shape, perhaps I could cut it, two of them side by side. Like this. So I've got 2 cube nets, like this, and now the waste material is what's being cut out of these corners here and in here.